Hello students, now we are looking at modulus and direction of a vector. The modulus and direction cosines of a vector in two dimensions. So when you talk of two dimensions, that means we are talking of the x and y components of a vector. Now if this happens to be a vector, OR is a vector. Now you realize that the x component is the horizontal this x is the horizontal component, while this y is the vertical component. Now the modulus of the vector can be found by the modulus of the vector is same thing as saying the magnitude of a vector. If you are talking of the modulus of a vector, you still mean the same as magnitude of a vector. So we use this sign, should two line in between so two lines like this show that this is a modulus, or you are talking about the magnitude of the vector. To calculate the modulus of the vector, you say that the square root of the square of the x component plus the square of the y component. So the direction of a vector along the x component. So this angle here is the direction of the vector along the x component. So along the x axis, it means along the x axis. So the value of the angle here is taken to be alpha. So if this is alpha, so to look for this angle, that means you say, well, this x component divided by the modulus of the vector, that is x over the modulus of the vector. To get the angle the vector will make with the horizontal axis. Now to get the angle the vector will make with the vertical axis, we are using beta to represent the angle the vector will make with the vertical axis. So that means you are going to look for the what, this y component over the modulus of the vector, that is cos beta is equal to y component over the modulus of the vector. That is, now let's apply this. Now if you are given this, find the modulus of 3i plus 4g 2 minus 2i minus 5g. To look for the modulus, you realize that this I the coefficient of x of I give us the x component, and the coefficient of g give us the y component. So now we said that to look for the modulus of the vector, if I use it, so that means if R representing the vector 3i plus 4g, so the modulus of R, so you put two lines here to show modulus of R, or it's known as the magnitude of R. So the square root of the square of this x component plus the square of this y component, so that is 3 square plus 4 square. So the square of 3 is 9 plus the square of 16 and 4 is what, 16. Everything find the square root. Making the square root of 9 plus 16 is 25. The square root of 5 is give us 5. So the modulus or magnitude of this vector is what, 5. Now for the second one, we are looking for the modulus of minus 2i minus 5g. So to get the modulus, you must show that our two lines, the vector is between two lines, like showing that you are talking about the modulus of magnitude of the vector. Then the square root of the square of the s component. The s component here is what, minus 2 square and plus minus 5 square. Then you minus 2 square is minus 2 times minus 2 will give us plus 4, plus minus 5 times minus 5 will give us plus 25. Then find the square root. 4 plus 25 will give us 29. The square root of 29 will give us 5.3852. So the magnitude of R is now 5.3852. Let's look at another question. The question says that if the vector R1 is 7i plus 3g and R2 is 2i minus 5g, find the modulus and the direction of cosine find the modulus and the direction of cosine. So now we said that, so first of all we are told that we need to add the vector r1 plus r2 and vector r2 minus r1. So first of all you need to resolve the vector r1 plus r2. So this is your r1, this is the vector r2. So you resolve it. So when you add it, open the bracket, you're having 7i plus 3j plus 2i minus 5j. Rearrange those one that is having I together. 7i plus 2i plus 3j minus 5j. 7i plus 2i will give us 9i minus 3j minus 5j is minus 2i. So the modulus of r1 plus r2 will give us the square root of the x component and the y component. The x component is 9 square plus y component is minus 2 square. 9 square will give us 81 minus 2 square is what? 4. 81 plus 4 will give us what? 85. You will now find the square root, which is 9.2195. Now we want to look for the direction of cosines. Now on the x-axis, direction along the x-axis, we said that we use alpha to represent the direction along the x-axis. So that means cos alpha is equal to the x component over the modulus. So we know that we talk that r1 modulus of r1 and r2 is so 9i minus 2j. So this is when we added r1 plus r2 give us this. So we are having this. So that means if you want to write it as a column vector, you can have it this way. So the x component of this vector is 9, the y component is minus 2. So if you are looking for the direction along the x-axis, so that means you say the x component, which is 9, over the y component and in the magnitude of the vector, which is square root of 85. So 9 divided by the square root of 85 will give me 0.9762. So if I now look for this angle, so cos alpha is now equal to 0.9762. So the angle it makes with the horizontal axis will now be what? The arc cos. You now look for the arc cos of this, which will give me 12.53. Also we need to get the direction along the y-axis. The direction along the y-axis. So here you know that along the y-axis we are using beta to represent the angle it makes with the vertical axis. So now that is what y is y component over the modulus of the vector. The y component of this vector is what? Minus 2. So that means we are having minus 2 over the modulus of the vector is what? Of r1 plus r2 is what? Root 85. I'm having root 85. So minus 2 divided by root 85 will give us minus 0.2169. So to look for beta, we look for the arc cos of minus 0.2169. So you realize that the here cos is in the second quadrant here. So the value you ought to get will be in the second quadrant or the third quadrant, but the value we need to get here is in the second quadrant. So to get the value of minus 0.2169 in the second quadrant, you are having 102.53. Then the second part, which says that what? We should look for r2 minus r1. Then this the vector r2, this vector r1, we want to subtract. So open the bracket, 2i minus 5j minus 7i minus times plus give us minus 3j. So we are going to collect like terms. 2i minus 7i minus 5j minus 3j. 2i minus 7i will give me minus 5i minus 5j minus 3j will give me minus 8j. So the modulus of this will now be the modulus of r2 minus r1. The modulus will now be what? The square root of the square of the x component, which is minus 5 square, plus the y component, which is minus 8 square. Minus 5 square will give me 25 plus minus 8 square will give me 64. 25 plus 64 is 89. So the square root of 89 will give me 9.434. Now, to look for the direction of along the x-axis, so we are going to use the formula cos alpha is the angle it makes with the x-axis. So cos alpha will now be x component over the magnitude of the vector. So already we know that R2 the vector R2 minus R1 is this minus 5gi minus 8j. You can write it as the column vector. So minus 5 is the x component, minus 8 is the y component. So here what we needed here is what? The s component, which is what? Minus 5 over the modulus of the vector root 89. So minus 5 divided by root 89 will give me minus 0.5300. So now to look for alpha here, I'm going to look for the arc cos of minus 0.53. So since here cos it should be in the second quadrant, cosine is negative in the second and the third quadrant. So I will look for the equivalent in the second quadrant. So this we should give you 122.01. So that means the y component is 122.01. Also let us look for the direction along the y-axis. So cos beta will be what? Y over this the magnitude of the vector. So that is cos b. The y component here is what? Minus 8. So the y component is minus 8 over the magnitude of the vector, which is root 89. So when you look for 8 minus 8 divided by root 89 will give us minus 0.8480. So to now look for beta, so it should be you look for the arc cos of minus 0.8480, which should give us 148 degrees. So for the work practice, you are going to have this. The vectors a, b and c are given by vector a is this, vector b is this, and vector c is this one. Then you now find the modulus and the direction of cosine. 1 a plus b plus c, then 2 a plus 7b minus 4c. Then the second question, the vectors a, b and c are given by vector a is this, vector b is this, and vector c is this. So find the modulus and direction of cosine of 2a plus 3b minus 7c to 4a minus 5b plus 3c. Please ensure you like, subscribe and comment on this video. Thank you.